Hello, everyone, and welcome to the show. This is the Critical Thread, where we're going to have an exciting show to do a deep dive into some aerospace stuff. But first, Andrew, what show is this?
This is the Critical Thread, everyone. The critical path along the digital thread. In other words, the fastest route from product idea to delivering it to the hands of your customer. It's our way of resolving your organizational bottlenecks through people, process, and technology enablement. And today
we have a fantastic guest. This is going to be an exciting show, some real great deep dives in the Critical Thread. We're bringing on Andreas Lindenthal, who's got over 25 years of experience in everything. He was a former executive in Siemens, a former head of new production. He's got an MBA. He's got all sorts of credentials. He is the founder and managing partner of PLM Advisors, and has worked for such companies as Apple, ATK, Moog, Sierra Nevada, Thales. The list just goes on and on.
So let's talk aerospace and defense, bill of materials and configuration management. Ready, set, go.
Hey, Andreas, welcome to the show. We're so glad you could join us today.
Hello, everyone. Hello, Brian. Hello, Andrew. How are you?
Good morning.
You're
good morning, neighbor. How are you?
Good neighbor.
Is this now Mr. Rogers show happening? So we just gave a talk about you having a pretty cool list of credentials, but I'm curious. Let's say we're stuck in an elevator. We make the mistake of saying, "Hey, who are you?" What's your answer to that? Your elevator speech, so to speak.
Sure. Well, I guess I would start with, hey, I'm Andreas Lindenthal. I'm the founder and managing partner of PLM Advisors. Originally, I'm from Switzerland, studied mechanical engineering, then did an MBA here in the United States, and have worked in the PLM space pretty much my entire professional career from actually even before that, and in college, my emphasis was already in computer integrated manufacturing, so kind of the predecessor of PLM. And again, worked in product development, implementing PLM for a Swiss manufacturing company, worked for Siemens, and then worked at two of my own PLM implementation and consulting companies. And then I have 2 kids, and I love to ride motorbikes, and I haven't gotten into flying yet. But who knows? That might be on the horizon.
This time, yeah.
No pun
This
intended.
time, yeah, you got it. So let's talk the digital thread. Let's talk that critical pathway. How would you define the digital thread in the context of product development, and how does it extend to covering processes like EBOM, MBOM, PBOM, bill of process, to ensure a seamless flow of information?
Sure, yeah. So in general, I think the digital thread refers to an environment where the entire process, so all involved systems, all product related data, and all people are integrated from inception to concept, development, sourcing, procurement, quality, manufacturing, delivery, support, and of course now even increasingly recycling and also disposal of products. And as I said, everybody involved in all these activities in that process. So that means employees and partners and suppliers and even customers. They all have access to the same current information and also to largely the same systems. In terms of
EBOM, MBOM.
Right. In terms of EBOM, MBOM, PBOM, etc., it means that all the business processes and systems that are integrated, that are required to create those BOMs, are integrated in such a way that the information that is acquired, so parts, sub-assemblies, tool fixtures, procedures, work instructions, documents, that are all available and synchronized between all these different systems that are involved. So in typically, in an aerospace defense environment, we talk about PLM specifically, ERP or MRP, and then all this information is synchronized with all the other systems that consume and need that information. So those BOMs, such as MES, MOM, CRM, customer relationship management, possibly for product configuration or customer product configuration, and SCM, supply chain management, and of course all the partner, supplier, and customer systems as well.
Yeah. So a lot of benefits. What are the other kind of general benefits and applications of the digital thread, critical thread?
Well, having all these processes and systems and people integrated through the extended enterprise really increases primarily the efficiency of executing a process and eliminating non-value added work. So basically, when you look at the process, and how a process looks, it consists of different steps. And so you go from, step 1 to step 2 to step 3, right? And each process step has a lead-in period. And that lead-in period typically is searching the information that I need to do my work and getting it into the format that I needed and so on. So I have to prepare the actual work. Then I do the actual work. And then to go to the next step, I may save it into a system, and then I send an email to the next person and say, okay, so please, I'm done with my work. You do your work now. And then the next person has to transfer the data, potentially export it from another system or from the previous system, import into the next system. So that might be re-entering it. Or do whatever it needs to be, reformatting it. There may be a whole bunch of activities involved, and then again do the preparation of the task, do the actual task, and so on and so on. So it goes through the different steps. So that all this lead-in period, the data transfer, all that is non-value added activities. It's required to do the work, but it doesn't add value. It's not actual the doing product development. It's just, well, I have to do it, right? That's in a non-integrated environment. In an integrated environment, like we have with the digital thread, everything is in one system, and a lot of this preparatory, the lead-in period, the data transfer, all that is not required anymore. It becomes much more efficient. it becomes much faster. Obviously there's less effort involved, and I save a lot of costs. So those are really the primary benefits of having a digital threat.
So it sounds like
multiply that by hundreds and thousands, because that's typically what it takes to go from concept to manufacturing. That can save hundreds of thousands and millions of dollars in non-value added activities.
With all of this, these benefits that seem significant, we know that nothing good just comes from free, right? So what are the challenges and considerations involved in setting up something like this?
I think one of the main challenges today in companies is that there's lots of silos today. Engineering has its own systems and processes, and quality has its own systems, and manufacturing has its own systems, etc. And every functional area is really primarily responsible for their own systems and processes. There really is, and of course, IT is there, and they support these systems, and they make sure that it's always the latest version and those sort of things, and they're running properly. But there really is no overall responsibility for the entire process from the beginning, from concept to support, and to the end of the process. And that is a challenge today, and that is a challenge for companies to get out of the silo thinking, and to get away from having individual applications to standardizing on applications. And there's different ideas around today. Some say the CIO should have that responsibility. Some say there's a COO, and then some say there's a new position maybe that's called a CDO, Chief Digital Officer. And we can talk about that probably in an entirely new or different webcast. But the key point here is that this overall responsibility, this overall person who has responsibility for the digital threat, really does not exist today, and hence, I think companies struggle with actually realizing such a seamless digital threat.
Are you saying that you think that somebody like that should exist? Like we should have a person whose sole responsibility is being the digital threat manager? Or are you seeing a world where each individual silo
data continuity
better?
Yeah, absolutely. There absolutely should be someone like that. I mean, it doesn't have to be a new role.
Is that the CDO? Is it the Chief Data Officer, do you think? Or is it the COO business?
Again, I mean, I don't think it really matters. It's the COO, the CIO, whether we create a new position of like a CDO, the Chief Digital Officer. I don't think it really matters. I think what matters is to give that person the authority and the responsibility to coordinate with the different functions, and also to tell the different functions, look, we need to go away from this silo island thinking and everybody for themselves and looking for what works best for them, to more an approach where what is best for the whole company.
Yeah. As long as it's someone senior taking responsibility for these data silos or these people silos or these departmental silos and bringing everybody together. Yeah, couldn't agree more.
Correct. Yeah.
Examples. So can you share a specific example from your experience where an effective critical threat implementation played a crucial role in accelerating speed to market for a product and considered the entire product life cycle through the E-BOM, M-BOM, P-BOM, BOP?
Yeah, maybe I have to start with that. I am not aware that there is a company today that has implemented this entire digital threat from the beginning to the end. I don't know of any company, but there is lots of companies that implement the part of it. And, even though, again, the concept is relatively old, actually, but as I said before, the problem, I think, today is not technology anymore. The technology clearly is there. But the problem really is more a people problem. It's driving the organization to making that change, to implementing that digital thread across the entire company. So, but having said that, one company I did work with a few years ago is a Swiss tooling machine manufacturer, where we did implement quite a significant part of that digital thread, and it's actually along the BOM. So where we really started at the very beginning from capturing customer requirements, and from those customer requirements, we created in an integrated way. We created a customer specific product configuration. And those were complex machines. We're talking about 40 independent, machine axes and those sort of things, with hundreds of options and variants and all that. So then from that customer configuration, by choosing, customer options and variants and all that, we would then basically use 150% BOM to pick all the options and engineering options and variants, the technical options and variants, and create basically a 90% engineering, customer specific engineering bill of material. And then from that 90% engineering bill of material, engineering would obviously add whatever was necessary for that particular customer to get to the 100% EBOM, customer specific EBOM. And then from that customer specific EBOM, 100% EBOM, they created the 100% MBOM. And that, again, was all in an integrated environment. And we get to the configuration management a little bit later, how that is important. And then from there, we would transfer that MBOM to the ERP system, where it then was used for planning, procurement, costing, and all those sort of things. And also, of course, the data was then transferred also to the MES MOM system for actual manufacturing execution. So that was a limited digital thread, but it was quite advanced for the time. And I think that's a pretty good place to be today.
Yeah, I think you just touched a little bit, or you touched a lot of it on configuration management and how it helped, with this one, let's say, smaller area of the whole digital thread idea. So if we look at trying to use proper configuration management inside of the digital thread, how can you integrate these practices so that we have accuracy across, the EBOM, the MBOM, the builder process, all of these things?
Yeah. So if we look at configuration management, the purpose of configuration management is obviously to ensure that products are configured, changed, and maintained properly throughout the entire life cycle. The digital thread, or integrating all these processes, systems, and people that are involved in configuration management, is really an enabler for configuration management. So having a seamless digital thread implemented makes it easier to go from requirement to EBOM, to MBOM, to PBOM, to SBOM, the service BOM, and keep the configuration of the product with all the revisions and options and variants and all the parts in sync and accurate between the different systems, so that I don't have a discrepancy between PLM system or an EBOM and the MBOM in the ERP system, for example. That everything really, the entire product across all systems really reflects the accurate revision, the accurate configuration of a product.
So we had a commenter here. Greg just asked, or basically said, we've got some good insights. And can you elaborate on the roadblocks or common hurdles that you encountered in implementing comprehensive solutions? But then he went on to add, like, specifically dealing with this Swiss tooling manufacturer, any lessons learned that are basically critical for overcoming obstacles and driving a successful digital thread adoption?
Yeah, I mean, I think we might touch on that a little bit later too. But I think one of the key pieces in the implementation at that Swiss tooling manufacturer was that the entire company was working together on making this happen. So everybody was working towards that goal. There wasn't engineering saying, "Oh, no, we want to use this system," and quality was saying, "Oh, we want to use that system," and manufacturing was on their own path. Everybody understood that they all had to work together and to integrate all the systems and make them work together, that in order to make that happen.
Yeah, that's great. Yeah, thanks for adding that to the discussion, Greg.
Yep.
We got another one come in here as well, actually. Do we want to take this now? From Nilesh Kumar Sharma. He's asking for any inputs on Cloud BOM.
On Cloud BOM.
It's a bit of materials in the cloud, yeah, I guess.
Yeah, I think there's no difference where the bill of material resides, whether that is in ERP, PLM, the cloud, in some system in the cloud. I think the key is to have that integrated, to make sure that the information is updated in a controlled fashion, obviously based on a process from wherever it is created. That may be a PLM system or a CAD system, locally on premise, to then at the right point in time to the cloud, so that it might be available for suppliers and partners and customers potentially. But yep. I think the key is integration, number one, and number two is process, that the data is updated in a controlled fashion at the right time, and then not, obviously not too late, but also not too early.
Yep. Yeah, Nilesh is picking up on industries these days are moving from PLM to Cloud BOM. Absolutely, they are. And I think, as you've said, Andreas, it's that integration across PLM, ERP, MES, MOM, making sure that that's consistently working bidirectional.
Right.
Yep.
Yeah, and when we say Cloud BOM, again, it's I think what we're really saying, at least that's how I'm interpreting it, is that the BOM is somewhere on a system in the cloud. That can be an E-BOM, that can be an M-BOM, whatever. But ultimately, it doesn't really matter where it sits. I think what matters is that it's integrated in the entire process, and again, that the process controls when the BOM is updated and how it can be used.
Okay, got it. So I know we've got more questions coming in, and everybody, please keep those questions coming in. We're going to go back to all of them, but next up for you, Andreas, in that transition from E-BOM to M-BOM to P-BOM to bill of process, specifically in aerospace and defense, how do you manage dependencies and changes, and what strategies do you employ to minimize disruptions and maintain a really fast-paced product development cycle?
Yeah, so today when you look at it, as we also just said before, most companies have a variety of tools and systems in place, and that traditionally has been a big problem to keep all those systems and the data in all those systems in sync. When we implement the digital thread, what this really means is integrating all the people, processes, and systems that are involved in creating, maintaining, and changing the E-BOM, M-BOM, P-BOM, BOP, bill of process, S-BOM, etc., and ensuring that all the different systems really stay in sync, and that any dependencies of data within a system or between systems are maintained, and that all the systems are updated when something is changed. So what is important to clearly define in this instance, number one, is that which system leads in a process, and which systems follow when something is created and when something is changed. Because one thing we really clearly have to avoid is that, say, for example, I create something in a PLM system, and then I transfer it to ERP. It should not happen that now someone changes that data in ERP. because if someone changes that in ERP and there's no feedback back to the PLM system, now I have two systems that are not in sync anymore, right? I have possibly one set of information in ERP, I have another set of information in PLM. And if someone now looks at the PLM system again and changes something, they may not know what they're impacting now in ERP. So that clearly, cannot happen. So it is really important that to implement a data governance policy and a clear data flow policy or approach, that we know exactly which system leads, where do I change something, and which system consumes the data. And it doesn't always have to be the same. I mean, it's possible that I change something in ERP, but then I just have to make sure that that information flows back into PLM.
Yep, got it. Let's talk digital tools, technologies for a moment. Considering how complex A&D BOM processes are, how do you leverage these digital tools and the technologies to streamline that flow of information and enhance the collaboration across the various cross-functional teams involved with all of these BOMs?
Yeah, so, tools are obviously a key part and enabler of the digital thread, right? So, without the digital tools, there is no digital thread. The key is to limit the number of those tools that companies use. Because, as I said earlier, the digital thread is really about seamless integration. And the more tools there are, the more, more tools have to be integrated ultimately, or using some middleware, so that the information can indeed flow seamlessly between the different systems. So to reduce complexity and cost means to reduce the number of systems or tools that a company uses. So we need to get away from, engineering having a PDM system and quality having a QMS system and ERP or manufacturing having an MRP system or potentially several MRP systems, etc., because it just increases complexity and costs ultimately. So when we look at the BOM process, there really shouldn't be more than 3 systems involved. CAD, when I start initially with the design, I create a CAD BOM, the product design, the product structure, basically. And then from CAD, the product structure or CAD BOM goes into PLM, where it is used to create the EBOM. And from the EBOM, obviously, I create the MBOM. And then again, there's the question always, do I create the EBOM, do I create the MBOM in PLM, or do I create the MBOM in ERP? And either way is fine. That's a decision a company has to make ultimately, and it's probably dependent a little bit on the complexity of the product. My experience is the more complex a product is that a company manufactures, and that is particularly true in aerospace and defense in many instances, the better it is to also create the MBOM in PLM, because I have one integrated environment, and when I make changes, I can easily see in one system what the impact is of that change. If I change the EBOM, I can immediately see which MBOMs are affected. If I change something on the MBOM, I can immediately see what parts on the EBOM are affected, what designs are affected, what documents are affected, etc. So I think that's the key, is to reduce the number of systems, to basically really 2 or 3 systems at the most. And then MES, I forgot MES, obviously once the MBOM is created, then I push that into MES and use it for manufacturing execution.
You bet. Andreas, we're getting busy here. We've got some questions coming in from the audience. Firstly, Chetan, Samira, thanks ever so much for your questions. Everybody, keep them coming in, please. This is good stuff. We've got one here from Chetan, which is opening up an earlier stage of what we call the critical thread, back in that requirements gathering stage where we're getting MBSE involved. So Chetan asks, would you shed some light on configuration management with MBSE? How is it used, and how to control the number of configurations getting created over time? How can a system architecture be sustainable to the growing configurations?
Yeah, that's a great question. I mean, obviously, if we create new variants and options over time, then that increases the complexity of the product. Absolutely, that's clear. So I think that the key is to decide, number one, what are the standard options and variants that I have available for certain requirements or whatever. If I say I have an in-flight entertainment system, and I want certain how many whatever programs do I want, etc. Do I how big is the box? How big is the hard drive, etc. Those sort of things. If now a customer comes and says, well, I want something else. I don't want the Panasonic in-flight entertainment system. I don't want Thales. There's a new supplier now on the market. I want that system. So now the question is, do I make this customer specific? Is that a one-off? Where I say, okay, just for this one customer, do I create that variant basically? Or do I make this a new standard variant? And that is a decision really that the company has to make, right? Is that going to become a new commercially available option, or variant in this instance, which of course increases the product or the overall configuration complexity, or is it just a one-off? Yeah.
I think we can agree that an integrated MBSC, the model-based approach to things, is the absolute way to go, and it's the real magical source of truth that you get there.
Absolutely.
There's another question I want to jump on, if I may, before we come. Actually, before we go to Samira, I was going to just talk. Nilesh has just put out here. Ultimately, EBOM is the source of truth. I've got an opinion that maybe the MBOM is. Because that shows you can actually build the dream. But I don't know. What do you think, Andreas? Is it the EBOM that's the source of truth? Is it the MBOM?
Well, I think I would say the good answer of an economist. It depends. I think for engineering, it's the EBOM. For manufacturing, it's
For sure.
It's the MBOM. And say if you, for example, look at Apple. Apple doesn't manufacture anything themselves, so for them, the source of truth is the EBOM. If you look at an aerospace company that designs their own airplanes, well, the MBOM ultimately is what determines how and what exactly is manufactured, and what is used obviously for manufacturing. So I don't think there is a one source of truth. It really I think the answer is it depends from which perspective you look at. Functionally, the EBOM.
Very
from
diplomatic.
A manufacturing process point of view, the MBOM.
Yeah, that makes sense.
You bet. If you don't mind, we'll take one question. Can we take? Yeah, exactly. Yep. I think. Yeah, go for it, Brian.
So this, I think, it fits right in with kind of what you're just talking about here. But how does with configuration identities, so the location standards that need to be adapted to a new digital thread approach in relation to the EBOM, is there a better approach than just assigning numbers as configuration identities to products and to make it a more structured in the PLM system?
So let me get that question real quick.
Go for that, because I want to go simulation in a minute.
Numbers. I mean, numbers in the past have just been used because there was no other way, right? I mean, it was the easiest way to manage a part, to manage anything really. A phone number. With technology, I'm really not dependent on a number anymore. I can have a descriptive value. So, today the phone number is just a 10-digit number, but, you can just as well enter Andreas Lindenthal and the phone knows to call me. I don't have to enter, my phone number anymore. Same with, any identifier on a part today. The part number is just a unique identifier to make sure that I don't, confuse screw B. And with the location identifier, that would be the exact same. I mean, if I could,
I'm going to click on it.
Yeah, if I can click on it, it doesn't matter whether it's a number or it's something descriptive. The descriptive would make it easier, but to identify it, obviously. But of course, I also have to make sure that it's unique.
Yeah, that makes sense. Yeah, thanks. With this whole process of trying to figure out how we use digital thread across the configuration and product development lifecycle, another big thing that comes up a lot is simulation. We know simulation and analysis are super important, especially in aerospace and defense, right? So how do you integrate simulation and virtual prototyping into the digital thread?
Yeah, it's basically similar to CAD. Before I was just talking about CAD, how you start with CAD, and then how CAD is then, the information from CAD flows into the PLM. Same with simulation. It's for simulation, it's important that, again, also it exists in this integrated environment, that number one, I have easy access to the product data and the latest product information, obviously, so that I can do accurate simulation. So that's important. Then, of course, it's important that when I do the simulation, that the data again is available to everyone. But of course, it's also important that if the design changes, that someone is actually aware to basically redo the simulation potentially if the design really changed significantly or even a little bit, just to make sure that the change still works, right? And having done that or doing that in an integrated environment, just make sure that I don't forget to also do that simulation. I've seen many instances where a company made a change and they just didn't think about to notify the people who do the simulation that, hey, we actually need to rerun that, and they just assumed that it worked or just didn't think about it. And they made the change, and in the end, the design didn't work because they didn't rerun the simulation because some key characteristics of the product changed.
So, I mean, just quickly on that, have you seen specific instances where those kind of tools, simulation, virtual prototyping, has played a significant role on optimizing the design or addressing some of the complex challenges in BOM, BOM stages?
Well, I mean, that they played a significant role in the design, yes, and in the BOM, probably not directly.
Less
I mean, simulation probably doesn't affect the BOM so much. I mean, maybe the configuration, but I don't think that
does the design and then the BOM.
Yeah.
Indirectly. Yeah. Gotcha. Okay. Cool.
So I think it's fair to say we've been talking a lot about collaboration so far. I think we can all agree that collaboration is definitely a key in the product development lifecycle. Can you talk a little bit about how the digital thread fosters collaboration among different teams in like aerospace and defense? Let's say you got your design team, your engineering, your manufacturing, you build a process, and all of this trying to improve efficiency and speed to market.
Yeah. So, a key requirement for collaboration is obviously the ability for the collaborators to do access and work with the same data simultaneously and instantaneously and to also follow the same process. Having everyone, work in sync, basically. Having a seamless digital thread, with integrated systems and processes enables obviously that instant and simultaneous access of data that is required to collaborate. So a continuous digital thread, for example, allows procurement to see products that are still in development and collaborate very early with engineering, with suppliers to get, for example, cost estimates, get early quotes. and source, for example, long lead items long before the entire product is released, so that you can get ahead of the game, as opposed to wait until the entire product is released, and then the information goes somehow into an ERP system, and then once it comes into ERP, then the demand is created, and then then in procurement, oh, okay, I need to order something, or I need to get a quote for something. Now I start my process. So now I'm way behind. So that, I think, is a key part of collaboration, and how the digital thread can improve collaboration and increase speed and efficiency.
Is this the kind of do you have a real world example of this?
Yes, I do actually. Many years ago, I worked for, again, a Swiss company, and the scenario there was that for their products, that the company needed to order these huge steel forgings for valves, and the process had always been that initially the valve was designed, and then eventually, when the valve was designed, then it was obviously given to procurement, and procurement would go out and get quotes for these valve forgings, etc. And then it would take 3 months to actually deliver that forging. So everything was sequential, and that was a problem. So basically, the whole project delivery time was like 9 months or something like that. First the design, and then the lead time for the valve forging, and then we could finally start with the production of the part. What we changed is that we basically initially only created the envelope of that valve forging of that body, and then that was then made available to procurement, and they could now start working with that valve forging, with that envelope, and engineering just had to make sure now to stay within that envelope for the valve. But that was really only possible because we integrated, or we gave procurement access to the engineering systems, and we transferred that information then very, very early from the engineering systems to MRP or ERP, where then procurement could start getting quotes for those valve forging and actually order them. So that was basically that was basically the process, but it reduced the overall process execution or delivery time by about 3 to 4 months. It was significant.
Well, Brian, do we want to take a question in from Chetan once again on verification and validation? Chetan's got you here. He's got you. The verification and validation and the service BOM greatly varies with the configurations, and the traceability back to the requirement is a challenge. How does a digital twin and simulation help with VMV and SBOM?
Yeah, it basically, yes, absolutely. Traceability of requirements and the EBOM, MBOM, SBOM is always or often a problem. Yeah, it's as soon as you go from different systems, you have a requirements management system. You may have an EBOM system, an MBOM system, and then potentially a service management application or system. If those systems are not integrated, then it's very, very hard to make or to determine, if I change this requirement, what impact does it have on an EBOM and an MBOM, on a service BOM, and the final configuration of the product, that and simulation and all that. So that's extremely hard. So the digital thread, obviously, through the integration of everything, make sure that if I change a requirement, I can see what is impacted, and vice versa. I can also see, if I change the design, does that still meet the requirement, or which?
And the digital twin is dynamic. It's the simulation. Yeah, you can test things dynamically, not theoretically. Exactly. So
Exactly. And I can very quickly, and that's really what it comes down to. I can very quickly determine what the impact is. Of course, I have to change it, and the change may even flow through all the systems. But what's really key is the decision making, because what I've seen often happens is the customer changes the requirement. Oh, the plane needs to consume a little bit less fuel and whatever, and I don't even know, in order to make that happen, what components would even be impacted by that. This information just is not connected. And then of course the research starts. Okay, so if I change this requirement, which components would be impacted by that? Which components were designed based on that requirement?
A digital twin as part of an MRO execution approach, to me, is just common sense, critical, cost saving, time saving. It's huge. It's huge. I mean, that ability to simulate MRO, never mind manufacturing or product itself, is a big thing. So I think it's a big value add. Really is.
Oh, absolutely. Absolutely, yeah.
Let me move you into a slightly different area now, version control. Considering the dynamic nature and these collaborative efforts we're talking about in A&D projects, how do you address those challenges related to version and control and ensure the teams across the different disciplines are working with the most up-to-date and accurate information?
Yeah, this again goes back to really the integration. If I change, for example, a version or revision of a part in PLM, and I have a separate ERP system or downstream systems, that can be an MRO app or whatever. Yeah, it's hard, because I really have to remember that if I change the revision in PLM, that now someone has to manually also update that revision in ERP and in MRO and then in everywhere. And that often, unfortunately, gets forgotten, right? With the digital thread, if I have everything integrated, that is now ensured that if I change it in PLM, of course, I have to design the processes correctly. But if I change something in PLM, it will go to ERP if I follow the right process, go through a proper change process, and I change it, then the process will make sure that the latest revision is now automatically pushed into ERP, and hopefully I make sure that in ERP nobody changes the revision. So I probably have to lock down the field if I even manage revisions in ERP, which again we could have an entirely different webcast on.
Yeah.
Yep. So critical thread is speed. Digital thread is consistency. Talking of data consistency, standardization in, again, A&D, what role does that data consistency and standardization play in achieving a smooth transition from EBOM to MBOM to PBOM to BOM? And how do you address those challenges related to data quality and accuracy?
Yeah, so purely from a technical point of view, a digital thread with fully integrated systems and proper data governance, so meaning a clear policy which system is the lead and is used to create and manage which data, ensures that all the systems have current and accurate set of data. So that doesn't mean that everything has to be done in PLM, for example. And ERP is just a mirror of PLM. And a possible process, for example, for part costing could be that I initially have an engineer enter the information of the estimated cost of a part in PLM, right? And then when the part is released, this cost information, along with all the other information, is transferred to ERP. And now, and I think I talked about earlier, that procurement can now use this cost estimate really as a guideline for sourcing the part. And once they have that final cost from the supplier, procurement updates that information now in ERP, and then that information is transferred back to PLM, where the original estimated cost is now overwritten, and now engineering can use that actual cost as a basis to do better designs, to do cost estimates for new designs, etc.
Yeah.
So what's really important, is that it's clearly determined who and what system is responsible. So that the systems are configured in a way that nobody has, everybody has the proper access, obviously, but nobody has access to change something that they're not allowed to change. So that to basically have a good data governance and a data flow policy, I think that's really, really important.
Mm-hmm. Yeah. So as you're diving into this, it kind of just made me think about the fact that digital thread is something that is kind of a new concept and kind of an old concept, right? Like it's always constantly evolving and moving along, and where this is going to go, I don't think we all fully know yet. But I'm curious how you see some of these newer technologies that we've have, IoT, artificial intelligence. How is this going to influence the EBOM to MBOM to PBOM to BOP process? And what benefits or challenges do you anticipate happening for A&D here?
Yeah, great question again. So, having the digital thread implemented is, in my opinion, just an absolute prerequisite to efficiently and effectively use AI and IoT, especially when you consider, how much data that is created or has to be created or is created in an IoT application. It's one thing to put sensors into a product and get real-time feedback from the field, but the data has to be acted on, it has to be processed, it has to be analyzed, and it has to then be made available to the right people and systems so that they can use the data to make the proper decisions. Because otherwise, why do I collect the data if I don't use it really? So ultimately, when implement whatever conclusions were drawn from that data, so without integrated systems, so without the digital thread, I basically cannot implement AI and IoT, or specifically in this instance IoT. That it's too much data to manually process and then act on. Similar with AI, there though it's a little different. The key is to giving AI access to information so that it, obviously, can be taught all the knowledge, and then that of course the AI can then answer the questions, or can act on that information that I taught it, that it was
Yeah.
fed.
So what's
Right.
being taught is pretty important.
Say it again.
I said, so what's being taught is pretty important, which is not only true for, let's say, artificial intelligence, but also true for personnel who are working on stuff, right? It's like we've got in aerospace and defense, we've got training, simulation that all has to happen. How are you seeing the integration of augmented reality and virtual reality technologies impact training programs or preparedness?
Yeah, again, also, AI, AR, sorry, and VR and all that. I think that's still, fairly new. It certainly hasn't been widely adopted. I think companies play around a little bit. There's some early adopters that have implemented some things, but it really, again, is just, when we talk about these new technologies, the key is that I have to have all this information available. I have to have the design information available. I have the configuration information available, and AR and VR really just can bring everything together and then use that data in a very exciting and beneficial way. But the key really is that I have to have the fundamentals in place first, because again, otherwise I just look at some nice pictures and I can't really act on that. I need to have, for example, I need to know what exactly is the configuration of a product that was delivered in the field, in order to be able to do, say, for example, a VR study on how I change a part. on whatever, an airplane or a product that is out in the field, right? Otherwise, I'm doing a theoretical exercise on, if the product really looked like that, then I could do it that way. But again, it's theoretical, because how do I know what it looks out in the field? So I really need to have that data first, how the product really looks, and then I can do a practical exercise. And JPL probably comes really close with that, because they do not only have a virtual prototype of the Mars probes, that are up there, but they actually have a physical prototype down here in Pasadena, where they basically can do studies before they apply that, to whatever the robot on Mars.
You bet. We got another question coming, but before we go there, Nilesh, thanks. We're going to come back to your question in a second. Considering, because we may cover it on this one, and considering the entire product development life cycle, E-BOM, M-BOM, P-BOM, BOM, how do you strike a balance between the need for agility and the importance of thorough configuration management to ensure product quality and compliance?
Yeah. So, one of the challenges in a non-integrated environment is that agility and thoroughness are almost always mutually exclusive. If you do things sequentially, which you would have to do to ensure quality and accuracy, the process is slow. If you do things in parallel and to do it faster, then often the quality and accuracy suffer, because people work with the wrong data. So I made the example of with the long lead item, right? If procurement gets the data before it's released, they might order something, but if then engineering changes the data again and procurement isn't aware of that, then you have the wrong part on the shop floor. So that's that's obviously not good. So again, the digital thread, having everything integrated, just ensures that, number one is I can do things in parallel, hence I can speed things up. And that whenever I change something in one system, that the other systems immediately are aware of that. Hence, I ensure that the accuracy is still there. So the digital thread is really, in my opinion, a prerequisite to do things faster and more accurate at the same time. Otherwise, one
I
or the other.
agree with you. Totally agree with you. Kind of speed, integrated concurrency gives you that real-time accuracy. Love it. I totally agree. This sequential way of design that we've done over the years is just far too slow for today. Has to be. Good stuff. Brian, we had a question from Nilesh, and perhaps we semi-answered it, which was, suggest us the checklist before releasing data into MRP, or checklist before creating a BOM.
The checklist before releasing data to MRP, or checklist before creating a BOM. Yeah, I don't know if there's just a standard checklist. Obviously,
there has to be checks and balances at every stage, doesn't there?
Right. I think I'm not sure how to answer the question. If there is a checklist before creating a BOM, I mean, obviously, all the parts have to be there. Then I have to see, what the revision is of the parts. And of course, when I release a BOM, all the child components, they have to be released. So that is very important. I should never release a higher level BOM before.
He's kind of qualified his question. He said, suggest as a checklist before creating I guess the E-BOM. I think perhaps what you're saying here, Nilesh. Yeah, I think so. There has to be a checklist before any BOM to make sure that there's some integrity. Yeah.
Right. I know. I mean, of course, one thing, before I go into an M-BOM, for example, or when I create an M-bomb, one of key is, I guess, to make sure that all the components on the E-bomb were actually consumed on the M-bomb and used. That is an important check that I would have to make, that I'm not forgetting something. And again, that is a key benefit of having an integrated system, and or actually doing E-bomb and M-bomb actually in the same system is that many systems have that capability to make sure that everything that is on the E-bomb has actually been used on the M-bomb, that I'm not forgetting a screw or some whatever, gadget or whatever. And then obviously, it's forgotten then on the shop floor.
Mm-hmm. You bet.
I think we've got one.
Brian, did we want to go back to Greg's question?
I think that's what I want to do. Is I think this will actually help with a little bit of maybe kind of wrapping up the show anyway, which is when we're talking about configuration management. Greg actually asked two questions here. The first one was, can you share specific examples where you've seen configuration management within digital thread play a critical role in compliance and industry standards and regulatory requirements? So have you seen that happen with configuration management and digital thread?
Just trying to think of a good example. Yes, I have seen it. Yes, to answer the question in general, yes. I'm just trying to think of a good example.
And the follow-up that might go with that too is how are you addressing those challenges related to the standards changing in regulatory frameworks?
Yeah. So I think the key there is that to have, again, an integrated requirements management solution, and it doesn't have to be in the same system, but it should be integrated in such way that if a requirement changes, and that can be a regulatory, an environmental, whatever requirement, that I can determine which parts, components, products were designed based on that requirement. And yes, actually, I probably have to go a little bit outside of aerospace and defense, go to the medical device industry. There, I've worked with companies. They use services basically that constantly scan the regulatory requirements and environments basically in different countries. So Japan has a different regulatory body than Europe has, and the United States, they obviously the FDA, and they really constantly scan that. And if something changes in any one of those countries, then they update the regulatory requirements in their system, and then the requirements management system of the company will be basically updated, and they will be alerted and say, this has changed, and now you need to change your requirement. And then, of course, when the requirement changes, then I have to determine what impact that now has on products. So, for example, if a certain material all of a sudden becomes illegal to use, then I have to change all products and parts that currently are manufactured with that material.
You bet.
Cool.
That's great.
Yeah.
Brian, I think we're there.
I think we did it. We have an hour full of some really good stuff.
That's great. And I'm going to say a big thanks, not only to Andreas, but to Chetan, Nilesh, Samira, Greg. Thanks for your questions. Great questions. We really love it. The chat stays open. So if anybody's got any other questions, throw them in there. We're going to jump on those, try to answer those for you one-on-one. But thanks, everybody, for joining us on today's show.
Yeah. And thanks very much, Andreas, for being here and giving us an hour of your time.
Of course. Yeah. Thank you very much for the opportunity. And thanks everyone for attending. Yeah.
Cool. We'll see you all in the next Critical Thread.
Sounds good.